Hello students, this video is designed to help with the problem sets from Unit 3. We're looking at the first 3 problem sets, lessons 1 through 3. Just like every other time, if you haven't already done so, please try to answer these questions by yourself, and then come back to the video, unpause the video, and see if you got them right. Alright, for the first problem, it asks for what statement is not always true. We're looking for a statement that doesn't get proven by this construction, which is a construction of a perpendicular bisector. First of all, AB is perpendicular to CD. Well, that's true because a perpendicular bisector is going to be perpendicular. It forms right angles by default. AB is equal to CD. Well, we don't know that. AB and CD are different line segments that weren't constructed to be equal lengths. For number 3, AE is equal to EB. Well, that's true because AE and EB are the two bisected pieces of line segment AB. And then CE is congruent to DE. From C to E, from D to E, they're the same because they're intersected arc points connected to the same point in the middle. So they're the same distance. For number 2, you had to use a compass. I have this fancy electronic compass, but hopefully you have yours by now. I think the last time I saw them in the dollar store, they were like $4. Using a compass and a straight edge, construct a perpendicular bisector. So what we've done was we took the, let's see if I can get my tool right here. We took the compass and we set it to point B and drew an arc. Then we flipped the compass, kept the same exact measurement, set it to point A and drew an arc, and then connected those two intersected arcs. Keep in mind that the line that you draw has to be straight. In classwork, I've seen students just connecting this line just by hand or by sight. It must be straight, so you must use your straight edge. That's why they specify using a straight edge. If you don't draw a straight line, you may lose points. For number 3, it asks you to do the same thing, but it asks you to do it 3 times. So this was a little confusing for students. They were saying, well, where do I draw the perpendicular bisector? It says construct the bisector of all 3 sides, so you need 3 bisectors. Moving on to the second page of problem set for lesson number 1. Again, pause the video, try these questions, and come back to see if you got them right. Alright, essentially this question is asking you where the fence is going to be. And the fence has to be in between these 2 parks, and it divides the 2 parks equally. So the first thing I did was I drew a line segment connecting the 2 parks. That's not where the fence is going to be. That's just a line segment that represents the distance between these 2 parks. I know that the fence has to be equidistant from both of these parks. So that means I did a perpendicular bisector construction, which was very similar to the previous perpendicular bisector construction using my compass. From A down here to B up here, that's going to be the fence. It didn't really matter where you extended it from. It just asked you to build a fence which divides the 2 parks equally. So you could have extended these lines to the edges of the paper. It did not matter. For question number 5, it asks you to draw a median. Sometimes in the problem sets, it's going to ask you to do something that wasn't explicitly gone over in class, but if you looked up what median meant, median of a triangle is a line segment from a vertex of the triangle, vertex is a point, to the midpoint of the side opposite that vertex. So we had to go from A, which is this point, to the midpoint of the side opposite that vertex, so the midpoint of BC. In order to find the midpoint of BC, I need to bisect BC. In other words, construct a perpendicular bisector. So here's the midpoint, connected A to that midpoint, and there I am drawing a median. For question number 6, it was another thinker. It asks us to construct a square inside of the given circle. That means I need 4 points around the circle evenly spaced. I need all of these points to be evenly spaced apart. The first thing I did was draw a diameter through the circle. I could have drawn any diameter. Notice I drew this blue one. I could have drawn it anywhere. The next thing I wanted to do was construct a perpendicular bisector because I have these 2 points, which are here and here. Those are on opposite sides of the circle. I need one up here and one down here that are evenly spaced around the circle, which means I'm going to make my perpendicular bisector. That's in red. And then the purple step, I now have these 4 points. This point and this point represented by the diameter, and this point, which I found using the perpendicular bisector. If I connect those 4 points with straight lines, that means it's got to be a square. That means this line is congruent to this line, is congruent to this line, is congruent to this line. You know what a square is. It's the one with all the sides equal. Moving on to lesson 2 problem set, pause the video, try these out, and then see if you got them right. For the problems in this set, you could have used the ABBA method. We talked about the ABBA method in class. A, B, A, B. All of these angles are that have relationships between each other. Like, for example, A and A are congruent to each other, B and B are congruent to each other, and then A and B are supplementary. In other words, they add up to 180 degrees. I do A, B, and then from here I go down here, and since this is B, this is A, B. Now I have the relationships, and if I can determine that these two are both the same, then they're equal to each other. If this one's a B and this one's an A, for example, then they would be equal to 180. In this case, the given angles are both B, so they're congruent. We set up and solve. As a quick note, you need to understand and remember these definitions. These are alternate interior angles. Alternate interior because they are on different sides of the transversal and they're between the two parallel lines. Between means interior. Opposite sides of the transversal means alternate. For this one, it gives us information about QR is perpendicular to ST. That means that this is a right angle. We're using the triangle sum theorem, essentially. Angle plus angle plus angle is equal to 180. We know this 90. We are able to find this 63 using alternate interior angles. In other words, angle 1 is equal to 63 degrees, and angle RTQ is equal to 63 degrees, alternate interior angles. Once I found that information, I was able to use the triangle sum theorem to find 27 degrees as my third angle. That's angle number 2. In this diagram, we're using that ABBA method again, AB, 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 AB. Notice that angle number 2, which is given to us, is an A. Angle number 3, which is given to us, is a B. Since those two are different, they're supplementary. That means we add them to 180 and we solve x equals 23. We're looking for the measure of angle 1. So angle 1 is an A, which means that it is the same as angle 2. So whatever angle 2 is, which is 3x plus 17, angle 1 is exactly the same angle. So 3x plus 17 again. For this question, it asks which statement is true. Notice that they gave you some of the angles. You had to solve all the other angles and then find out that this set of angles and this set of angles were exactly the same. If these two sets of angles are exactly the same, that means that this line and this line are going to be parallel to each other. They're parallel because this transversal separates them into the same exact sets of angles. For this question, it asks us to find the measure of angle 1. Angle 1 is an A. If I label all the angles, angle 2 happens to be a B. So that means that if one is A and one is B, that they are supplementary. Set them up and solve for x. And then it's asking for the measure of angle 1. So that means I need to substitute x into angle 1. Remember, if it's asking for a specific angle, once you find the value of the variable, you got to substitute it in. In this question, we are told that we're looking for angles 1 and 2. Angles 1 and 2 are alternate interior angles. That means they are on different sides of the transversal and they're between the two parallel lines. Both angles 1 and 2 are A's when we do our ABBA method, so that means we're going to set them equal to each other. X is equal to 15. If I was trying to find the measure of angle 1 and the measure of angle 2, I would substitute x into this expression, so 7 times 15, whatever that happens to be. 15, 30, 45, 60, 75, 90, 105. 105 would be this one, and 105 would be this one as well. Lines P and Q are intersected by line R, so that means line R is a transversal. Again, we use our ABBA method. We find out that angle 2 and angle 1 are different. They're supplementary. They are also known as consecutive interior angles because they are on the same side of the transversal, that's consecutive, and they're between the two parallel lines, that's interior. Set up and solve. It asks for a value of x, so once we find x, we are done for that problem. Here's another transversal. We use our ABBA method to find out that this angle and this angle, which is TVQ and VWS, are both B's, so they are congruent. If they're congruent, that means they're equal to each other, so we set up and solve x is equal to 16. It asks us to find the measure of angle TVQ, which means I substitute and solve. That's algebra, so I'm not really going to go over that. The next thing we're going to go over is the next page on that problem set. Pause the video, try these out, and see if you get them right. All right. It asks us what the measure of angle A is. We know their corresponding angles A and 53, so they're equal to each other. It asks what the measure of angle B is. Alternate exterior angles from here to here gives us that. And the measure of angle C, I know C is 127 because of supplementary angles. I could have also used that the measure of angle C and the measure of angle A are supplementary because those are consecutive interior angles. There are multiple different ways to solve these problems sometimes, so be sure to just justify whatever method that you find. In this question, I know that this angle, which is 35, is going to grow into this angle, which is 35 because of alternate interior angles. Then once I find that alternate interior angles, then I can say, well, 35 plus something is equal to 180, solve to get 145. For number 3, the first thing I found was that measure of angle E is equal to 54 degrees. 54 degrees because these are alternate interior angles. I also know that the measure of angle F is 68. Why? Well, I know that this is 112. This must be 68 because of supplementary angles. That's the first step. And then from here to here, 68 is congruent to angle F, or angle F is equal to 68 degrees because of corresponding angles. They're on the same place, but different intersections. Here we're introducing the idea of auxiliary auxiliary lines. If you didn't already know this, we go over it in class during lesson 3. I know that this measure is 144 degrees. If I draw an auxiliary line here that splits this angle into 2 separate angles, that means that 144 degrees and 35 degrees equals 180. That means that this angle is going to be 35 degrees. I'm using alternate interior angles for this one to find that these are equal to each other. This happens to be consecutive interior angles. They're on the same side of the transversal, and they are inside the 2 parallel lines. I did the same thing here. That auxiliary line, which is parallel to these other lines, that auxiliary line splits up angle H into these 2 angles. Sometimes when we do auxiliary lines, we call this one angle X and this one angle Y. I didn't even bother with that because it was easy enough to figure this out. This was 162. This is 18 because 162 and 18 combine to 180. That's that blue step. 82 is the measure of this angle because 82 and 98 is equal to 180. Again, that is consecutive interior, consecutive interior. Once we have 18 and 82, these 2 angles, we combine them together to give me 100, and that means that the measure of angle H is equal to 100. Moving on to lesson 3, this is the lesson that we really dig into auxiliary lines, which are parallel to the 2 parallel lines that are already given. Pause the video, try this out, and then see if you got the questions right. All right, this is the same procedure over and over again. We draw an auxiliary line that is parallel to the 2 pre-existing parallel lines. We separate the angle that we're looking for into 2 angles. In this case, we're using X and Y. Usually I separate them into X and Y, and then I find the 2 individual angles. Once I find these 2 individual angles, I can combine them to give me that big angle. So for example, this is 51 and this is 51, corresponding. This is 33, so this is 33, alternate interior. And then X and Y combined together gives me 84 degrees. Here, X is going to be equal to 51 because of consecutive interior. Y is going to be equal to 84 because of corresponding. And then I combine X and Y together to find the measure of angle 2, which is 135 degrees. Same thing here. This angle is 35, so this angle is 35 because of corresponding angles. In this case, it tells us that the angle is 67 degrees. So if I know this is 35, I have to subtract 35 from 67 to get angle Y. Turns out that angle Y is 32 degrees. Once I find angle Y, 3 is equal to 32 degrees as well. Angle 3 is equal to 32 degrees because of alternate interior angles. Let's see, moving on to this one, another auxiliary line, another X and Y. You get the idea. I'm not going to go through every one of these problems because they're very similar. For angle R, it's another situation where you draw an auxiliary line and separate it into X and Y. X and Y combine together to give you 96. If you follow the steps here, they are color-coded. You should be able to figure this out very easily. This is 130, so this is going to be 50 because of consecutive interior. That gives us that X is equal to 46 because 46 plus 50 is equal to 96. And then X and R are the same because of alternate interior angles. This next one didn't really use an auxiliary line. We first used alternate interior angles to find angle C is equal to 46. Then we used our exterior angle theorem. Do not forget the theorems that we've learned before. Exterior angle theorem says that these 2 remote interior angles equal that exterior angle, so we could figure that out pretty easily. This is the same exact type of problem, except there were 2 different auxiliary lines, 2 steps, not a big deal. All right, moving on to the last page, the proofs. Pause the video, see if you get them right. All right, here are the answers for the proofs. They are all very straightforward. They're all using the same exact properties. All right, hopefully this was helpful in trying to answer the questions from the problem sets from lesson 3. Good luck studying.